Okay, everyone, thank you for watching. And this video is going to cover how to conduct a multiple regression using IBM SPSS statistics. Now, that being said, let's give a quick scenario so we can follow this together. Let's assume that you work for an employer and that employer wants you to do an analysis to determine which ingredients that you currently have and will actually improve the quality of the product that you're selling. Now, in order to do that, first, there are some assumptions that we're going to automatically assume that we've done already. And if you want to know about those assumptions, please go back and watch the other videos. But for right now, we're going to go on the assumption that all of the missing data in this data set has been recognized and managed. Okay? And the second assumption we're going to make is that all of the outlier data within our data set has been accounted for and managed. So that being said, we're going to move on to the next phase, which is to look at our different variables to determine which one will most likely improve the quality of wine. And first, we're going to start with looking at the relationship between those ingredients and wine quality, only to help us better understand the multiple regression output when we get to that stage. So that being said, we're going to click on Analyze. I'm going to go to Correlate. I'm going to click on Bivariate. And I'm just going to actually select all of my variables and put them over to the variable section. Okay, I'm gonna leave it on Pearson. The difference between two-tail and one-tail. Even though the employer said which ingredients most likely improves wine quality, I'm gonna leave it two-tail because I want to see which ones will improve and which ones will most likely uh, not improve the quality of the product. So that being said, I'm leaving it on two-tail. Okay. Let's go to options. I'll click on means and standard deviations. That's fine. And I'm gonna click OK. All right. Now, so what you see here is we have our first, let's cover this. Um, I did tell the system to let me know all the significant correlations. So you can see here, if anything has two asterisks, that is significant at a 0.01, which is great. I mean, that's a great output to have. And then it will let us know with one asterisk that if the relationship is significant at 0.05. And normally 0.05 will be your acceptable level. Okay. All right, scroll back up. All right, so I'm gonna leave it right here at quality because this is what I'm trying to improve. And you can see that I have my ingredients loaded here as well. Now there's a one right here. And I'm going to explain to you why you see this one. This one means that your quality one goes with your quality. So quality will always, the variable when it's compared with itself will always result in a one. And another example of that is we just go here, you see this one, this is alcohol, and that one goes with alcohol. So you will see ones throughout your data set. You can just follow the cursor and that's how it should be. Okay, well, let's get down to why we're doing this. Let's see. Let's start with the highest correlation that we have. And when you look at your data, that's a negative, that's a negative. And a negative would mean that this is most likely going to not improve your product. It would actually reduce the quality of your product. Okay, we have a positive here, and is at two asterisks. Remember, that's at 0.01. That's great. All right, we have a positive number here. Ooh, we have a positive number here at 0.38. Hey, but something is a 0.44 and is at a 0.01. So this will be alcohol. So alcohol has the highest correlation with the quality of our product. Interesting. Well, let's see just how efficient this will be. So let's go to Analyze and run our multiple regression. And let's go to Regression and click on Linear. Okay, now dependent, we're looking at the quality of the product. Okay, so that's our dependent. And we want to know what ingredients predicts the quality of the product, most likely predicts the quality of the product. Now, so I highlighted all of my independents and I put them in an independent section. Now, this method enter, what I'm going to do here is I'm going to click on Stepwise. And the reason why I click Stepwise is I'm telling SPSS that within this multiple regression, I want you to load the variables that are the most likely to correlate with my dependent. And within there, stop loading when it doesn't become significant. And not only will it stop loading once they find that there are no other significant variables that relates to the dependent, it will actually put them in order from the greatest effect to the lowest effect. And that will help you look at your data and determine which ones will most likely improve the quality of the product in rank order. So that's what Stepwise is going to do for us. Click on statistics. I'll look for R squared. That's fine. I'm not going to click on the residuals. The Durbin Watson is normally set aside for your time series data, like your financial data, or if you're looking at something in a time series format. So I'm not going to check that. Plots, make sure your Z predictor, X will always be the predictor, and your residuals are always your dependent variable. And I'll look at histograms and normal PP plot. Okay. That's all we're going to do for this one. I just want to show you the readout of what your multiple regression will do. All right. So remember, I clicked stepwise, and remember we saw that alcohol was had the highest positive correlation with our quality of our wine. That being said, as you can see here, alcohol in our model, alcohol is 1. Then our acidity is 2, sulfates is 3, and residual sugars are 4, and so on and so on and so on. And it will only load all of your significant correlations at a zero point zero 0.05, less than 0.05. So that being said, if your boss or if you were creating a product or had a product and want to know which ingredients will most likely improve the product, now you know that within multiple regression, you put all your ingredients into the independent and the quarterly into the dependent, and you use the stepwise function in multiple regression, and you can effectively say that alcohol, acidity, sulfates, and residual sugars. If we can improve on these areas, we'll most likely improve our product. So I hope you learn how to do multiple regression using IBM SPSS statistics.